Hey guys, it's Howard here with MakerDaddy.com again. And in our previous lesson, number 5, we saw that we could blink our left and right LEDs using the push button. But there's still one little issue here that I wanted to fix, and that is, you see when we let go of the button, sometimes that delay still has to go finish up before we can actually stop blinking the lights. So if I'm holding it, I let go of it, then it still blinks and finishes those delays. I want to get rid of that. So let's go ahead and take a look at that and see what happens here after we run the new code for lesson 6. Okay, so I've uploaded the code for lesson 6. And we'll see now that when I press the button and I release it, the LEDs go out immediately. They don't continue to wait because we've removed that delay function. And now we're looping through and looking at the time. See how long those lights have been on? And should they be on still or off? And we activate that with the button. So let's go ahead and take a look at the code for that.
All right, so let's take a look at the code from lesson 5 where we did have the issue that we wanted to solve. So if you notice here in the loop, when we press the button, our button state is high, and we call blink light here, which will then turn for our left LEDs. So that turns it on for half a second. It uses a half-second delay, and then it turns it off with a half-second delay. And then we call the same method using the right LEDs, where we turn it on for half a second and then off for half a second. And the problem was that if we release this button while we're still in the middle of the code here, the LEDs will continue to flash because we are still calling this code, right? We have these delays and we're not able to stop those from turning on and going off until after it passes through that loop, until it completes that code, and then this is no longer true. When now the button state is low, then it'll stop. So what we want this to be more responsive, so when the button is pushed, the lights come on, but when we release it, the lights go off immediately without a delay. So let's go ahead and take a look at code for lesson 6. So here we have the same constants we had before with the left LEDs, right LEDs, and a button pin. We are initializing button state to be low, left LED state to be low, and right LED state to be low. And we have a Boolean for the left and for the right. A Boolean is assigned either a true or a false. It can be true or false. Yes or no, true or false. So left and right, we're assigning Booleans. And here we're setting an unsigned long, which is going to be called left previous millis. Millis stands for milliseconds. We're initializing that to 0. We're doing the same thing for right previous millis. Now, as it says here, you should generally use unsigned long for variables that hold time, because these can become very, very large numbers, much larger than an int can handle over time. Okay? Here we have a constant, which is another long, which is our interval, which is 500. This, again, will be 500 milliseconds. Okay, in setup, we set our pins for left and right LEDs to be output, for the button pin to be input, just as we did before. Now, once we get into loop, remember, the loop will run over and over and over again very quickly, unless you have a delay. And in this case, we're removing all of our delays, so it will continue to loop and loop and loop, unless you hit a piece of code inside here that causes you to do something else, okay? So right now we read our button state, just as we did before, from the button pin. And here we're assigning another variable, because this is inside our loop. This is considered to be a local variable versus the ones we declared outside, which were global variables, okay? So we're assigning current milliseconds to be equal to millis. Now, if we look at the Arduino reference, we will see that this returns the number of milliseconds that has passed since the Arduino board began running the current code. If you leave your board running over and over for a long period of time, approximately 50 days, you can actually overflow that number. It'd be too large for the Arduino to handle, and it'll go back to 0. But for ours, we're not going to be doing that. We're going to be running it for just a few minutes. And so basically, once we get the sketches uploaded and the program starts running, that's when our clock starts. Okay, so the current milliseconds. Now, for our case, let's imagine that we press a button, approximately 1 second after the code had been initialized, or the code had been uploaded. Okay, that's going to be our timestamp. Okay, so it did start at 0, and then it continued to go up and up and up, because we check it at 0 milliseconds, and we check it again at 1 millisecond, and 2, 3, 4, however fast your board is. Then that number will continue to climb over time. Okay, we checked our button state. In the very beginning, the button state is low. We set that earlier. So this would be false. Now we look down to see, if you notice here, I don't know if you've seen this before, but when I put my cursor behind this brace, I can see where that piece of code ends and the next piece starts. So I'm going to be running the else statement because the button is up in the very beginning. So we write LED left and right, we're writing low. Basically, we are setting low to the left pins and to the right pin. To 13 and 12, we're setting low. It means basically everything's off. Okay, the second we release that button, we turn them off. Now, after 1 second, we press the button. Okay, so now this condition is true. So we're going to run the if statement. Now we have another if statement. What we're going to do is we're going to check to see if the left LED should be on in this piece of code. And in this one, we're checking the right LEDs. Okay, let's go back up here. So our current milliseconds, as we said, we managed to press a button exactly 1 second after the sketch uploaded. So current milliseconds equals 1000. Left previous milliseconds is equal to 0. Remember, we initialized that earlier here. It's equal to 0. Our interval is 500. So now, left 1000 minus 0 equals 1000. Is that greater than or equal to the interval? So the interval is 500. 1000 is definitely greater than the interval. So you notice this operator here. This is called the AND. So what's going to happen with the AND operator is we're going to check if this is true and if this is true. So we just proved out that this is true. 1000 is greater than 0. So we're going to check the next statement, the statement on the right. Is left on true? And if you'll notice up here, we did initialize that to be true. Here. So this if statement is true for this operator is true here and true here. So we're going to run this piece of code. So what we do, the first thing we want to do is reset left previous milliseconds to be equal to current milliseconds. So before it was left previous milliseconds was 0. Now we're going to set it to 1000. Okay. Now if the LED state was low, we're going to set it to high. And it was low. We initialized it originally, both of them to be low. So now we're setting left to be high. And then we call, because the LED was low, we skip the else statement. We're not going to run that. We call right LED, left LEDs, and then left LED state. So for our left LED pin, we're going to set it to low. I'm sorry, we're going to set it to high because we set it to high here a minute ago, right? So we turn the left LEDs on with this statement. And then we exit and we check this code. Current milliseconds minus right previous milliseconds. So this is still 1000. This is 0. We initialized it. So 1000 minus 0 is definitely greater than 500, which is our interval. However, because the AND operator requires both sides to be true, and right on is actually false, we initialized that earlier to be false, this statement is going to be false. So we're not going to run the code within this if statement. So basically this if statement gets skipped. Now, imagine we just ran through all that code and it took us 1 millisecond. Now, if we're holding that button down, then we're going to see that the button state is still high the next time when we go back through the loop again. So we're going to check current milliseconds minus left previous milliseconds. So now if we say we just checked it again, so now it's 1001. But left previous milliseconds is equal to 1000. Remember we set this earlier. So 1001 minus 1000 is equal to 1. and that is definitely not greater than or equal to 500. So this statement is false, right? So we're not going to run this if statement, or the code within the if statement, because if the left is false, there's no point in even checking the right, because they have to both be true in order to run the code. So remember earlier we had written high to the left LEDs, so those are still on at this point. 1 millisecond in, left LED is still on. So we check this again. Current milliseconds minus right previous milliseconds. Okay, so it is greater, because current milliseconds is now 1001. Right previous milliseconds is still equal to 0. So this is true. However, right on is still equal to false. So this if statement will be skipped. So basically what's going to happen is that for that 1 millisecond period, we have skipped both of these two if statements. So the left LED light is still lit. We had written high to it, and that's it. Now, that will continue as you come back through the loop. It will continue over and over again for the next 500 milliseconds until we check again and we see that current milliseconds goes to 1,500. At that point, we're still holding the button. So current milliseconds is 1,500. Left previous milliseconds is still 1,000. Remember, we set that earlier. So 1,500 minus 500 is equal to 1,000. So that is equal, 1,500 minus 1,000 equals 500. That is equal to the interval, which is 500. And left on is true. Okay, so now we've met this condition again. After 500 milliseconds, that LED has been on, the left LED has been on, and now we meet this condition again. So we're going to assign left previous milliseconds is now equal to 1,500, right? We're going to set it because that's what current milliseconds is equal to. Now we check this if statement. Is the F LED state low? No, we set it to high earlier, remember? So we're going to call the else statement. And inside the else statement, we're going to set that LED state to low. We're going to set left on equal to false. And we're going to set right on equal to true. This is what performs our switch. All right, so now the left has been on for 500 milliseconds, but now we want to turn on the right one. So we write low, right, to the left LEDs and turn them off. Now, when we hit this piece of code, this is still 1500 milliseconds, and this is still 0 at this point. So 1500 is greater than 0. So this is 1500 is greater than 500. So this is true. And right on is equal to true now because we turn it on up here, remember? So now we do run this piece of code. So now we set right previous millis to be equal to 1500, which is our current milliseconds. And right LED was low. There's the initialization in the beginning. So we're going to set it to high. And we skip the else because we met this condition. And we're going to write high to the right LEDs. So now we're turning on the right LEDs. And we continue this loop. When we come back in again, just as we did before, say now it's the current milliseconds is 1,501. Well, left on is equal to false, so we're not going to run this. Right on is true, but 1,500 minus 1,501 minus 1,500 is only equal to 1, and it's not greater than or equal to the interval of 500. So this if statement will be skipped again, and it will continue to be skipped for the next 500 milliseconds. That's the half a second we want that right LED to be lit, and then we'll meet this again once we hit 2001 or 2000. So now 2000 milliseconds, that's 2 seconds into our program, minus 1,500 is equal to 500, and that's equal to the interval, and right on equals true, so we're going to hit this again. Now we're going to set right previous millis equal to 2000, and because the right LED is not low, it's high, we're going to go into the else. We're going to set right LEDs to low, left on to true, right on to false, and then we're going to write low to the right LEDs. So in essence, we had 500 milliseconds on our left, then turn it off, 500 milliseconds on our right, turn it off, and then start all over again. As long as we're holding that button down, we're going to run that code and loop through left, right, left, right. Now, if we release the button, again, we will write to the left LEDs low and to the right LEDs low, basically just turning them off immediately. So that's how we handle getting rid of the delays, just using time in milliseconds in order to determine if the LED should be on or off. And then we switch them back and forth by using our flags here, left on and right on. Now, on our next piece of code, or in the next lesson, we're going to learn how to make the button a toggle switch. So what's going to happen then is when we press the button and hit high, it will start our code, but we can release the button. And the code will still continue to run, the lights will still blink until we press the button again. That's basically turning that push button into a toggle switch. So I can turn it on, leave it, and then turn it off and leave it, just like it would like a light switch on the wall. All right, so in the description below, I'm going to include a link to the blog post. In the blog post, in the resources section at the bottom, you can actually find this code and you can copy this into your own and use it yourself. Please remember to like and subscribe, and I will see you in the next video. Thank you very much.